Hi guys, welcome to this easy maths video, and today I've got a problem from the UKMT Senior Maths Challenge 2010 paper, question 23. It says the diagram shows two different semicircles inside a square with side lengths of 2. The common centre of the semicircles lies on a diagonal of the square. What is the total shaded area? Got answers as A is pi, B is 6 pi multiplied by 3 minus 2 root 2, C is pi root 2, D is 3 pi multiplied by 2 minus root 2, E is 8 pi multiplied by 2 root 2 minus 3. Can you solve this problem? Pause the video to give it a go and then continue watching when you're ready for the solution. Here's the diagram enlarged. What I've done is I've drawn a line going through the centre of both the large and smaller semicircle. Now this line represents both the radius of both semicircles. Now we can let the radius of the small semicircle equal to r. And what we'll find is the radius from the centre of the semicircle to the edge. And what we can see here is there is actually a right-angled isosceles triangle, which I have displayed in red. So this means that both the side lengths of r are equal. So we can say that the red triangle is isosceles, therefore both the opposite and adjacent sides are equal to r. Therefore, using Pythagoras Theorem, we can say that the hypotenuse of the triangle is equal to the square root of r squared plus r squared, which is equal to root 2r. And therefore, that line that I drew going through both the centres of the semicircles, well, the line below the centre of the larger semicircle must be equal to root 2r. And now we can form an equation saying that r plus root 2r is equal to 2, because the line which I've drawn going through the centres shows that both the radius of the smaller and larger semicircles are touching the edges of the square. So the total of both of their radiuses are equal to the side length of the square of 2. So now we can solve the equation for r. So we've got r plus root 2r equals 2. We've got a common factor of r, so we can factorise that out. So we get r multiplied by 1 plus root 2 is equal to 2. Then we can divide both sides by 1 plus root 2. So we get r equals 2 over 1 plus root 2. And then of course here we've got a surd as our denominator. So what we can do is we can rationalise the denominator. And we can do that by multiplying both the top and bottom of the fraction by 1 minus root 2. And that gives us 2 minus 2 root 2 all over 1 minus 2. And that simplifies to r equals minus 2 plus 2 root 2. So we've got a value for r. I've adjusted the diagram slightly to show the value of both of the radiuses for both of the semicircles. And I've labelled the smaller semicircle as A1 and the larger semicircle as A2. So now we can calculate the areas. So we know that the formula for the area of a semicircle is equal to a half pi r squared. And of course, the radius of the smaller circle, A1, is equal to r. So the formula for the area of the semicircle is just a half pi r squared. Now, the area of A2 is going to be a half pi multiplied by root 2r all squared, as root 2r is our radius. If we expand that out and simplify, we are left with pi r squared. And now we can generate a formula for the whole area of the shaded region by taking the area of the smaller circle plus the area of the larger circle. So we get a half pi r squared plus pi r squared, which is 3 over 2 pi r squared. And now all we need to do is substitute our value of r into this equation. So the total area of the shaded region is 3 over 2 pi r squared. We know that r is minus 2 plus 2 root 2. So we can just substitute r into that formula. So we're going to get the total area is 3 over 2 pi multiplied by minus 2 plus 2 root 2 all squared. And then if you expand those brackets out, we can simplify it to this form where we've got 3 root 2 multiplied by 4 all multiplied by 2 minus root 2 plus 1. And we've done this because all of the answers are in the form of a factor multiplied by pi. So we take out a factor of 4, we can then multiply 4 by 3 over 2, and that gives us 6 pi. Simplify everything inside the bracket, so 2 minus 2 root 2 plus 1, we get 3 minus 2 root 2. So therefore, our final answer is 6 pi multiplied by 3 minus 2 root 2, which is answer B. Thanks for watching. Don't forget to subscribe. You can check out my other videos on this page. And also, if you've got any questions or any video suggestions, just leave a comment down below.